All right, our next topic is graphing quadratic functions using standard form. So previously we've talked about using basic graphs with our parent graph of x squared, and we have talked about using vertex form to graph a quadratic function. Now we're going to use standard form. So to show you what standard form is, it's something that you've all been familiar with and what we've been working with before with factoring quadratics. If I give you f of x equals a x squared plus b x plus c. Okay, so it's the same setup as what we've been seeing. Remember when we were factoring numbers like that, right? Your two parentheses and so on and so forth, right? So it's kind of that same form there, okay? But this time we're going to graph those. So here's how this works. So the first thing we're going to point out is that our c in this graph, or when we graph this, our c is our y intercept, okay? Basically, this tells us where our graph is going across the y-axis on the graph, okay? And then to find our axis of symmetry, basically where our parabola is going to, where the middle of it's going to be, axis of symmetry, we have to use the formula negative b over 2a, where we plug in whatever number we have here for b at the top, and then whatever number we have in for a at the bottom. Remember, our axis of symmetry is also the x of our vertex. Okay, it's the same thing, okay? So when we want to solve for our vertex, we're going to use this form here to find our x, okay? So let's do an equation, and let's graph a function in standard form. So let's use, I'm going to rewrite this a little smaller to the side here. Ax squared plus bx plus c, okay? So let's use an example. Let's do f of x equals 2x squared plus 4x plus 3, okay? So first thing we have to do when we graph this is we have to find our vertex, okay? And in order to find that, we need to use our vertex form, which is x equals negative b over 2a. Okay, now we're going to go plug in our numbers. So for b, our b is 4, right? Because we look at over here, our b is 4, so negative 4 over, and then 2, and then our a is also 2. So 2 times 2. Remember, when the letter is next to a number like that, we multiply them. So now we just solve what we have here. So negative 4 stays on top. Our 2 times 2 on the bottom is 4. And when we do negative 4 divided by positive 4, we get a negative 1. So if we write this out, our vertex, we know our x is at negative 1. Okay. Now we need to find out what our y of our vertex is. So to figure that out, we need to take our x, whatever we found here, and plug it back in for our x's in our equation and solve to figure out what our y is. So let's do that. So let's go f of x equals 2, and instead of an x, we're going to plug in our x, which is negative 1. That's terrible. Negative 1, okay? And that's squared, plus 4, and remember, instead of x, we're using our negative 1, and then plus 3, okay? So go ahead and solve. Order of operations, remember. So here, negative 1 squared is a positive 1. You can do this. 4 times negative 1 gets us a negative 4, right? And we're going to put that in there to differentiate it. And then bring out our plus 3. 2 times 1 is 2. Now remember, when we have if it's plus -4, we can just go ahead and write this -4. It's the same thing. Plus negative and minus is the same thing. Bring down our 3. 2 minus 4 is -2. And -2 plus 3 is a +1. So our y in our vertex is at a +1. So now we kind of know where we're going to go with our graph. Our vertex is at -1, 1. And our y intercept, look at our last one, is at 3. So if we draw a simple graph here, okay, we can go ahead, we can plot our vertex. It's a -1, 1. So from our 0, xy, -1, +1, draw our point. And then we can also plot our y-intercept. So our y-intercept is where it crosses the y-axis. So our y is our vertical line here. Our y-intercept is 3. So we count from our point, or from our origin here, 0, 0, count up 3. So 1, 2, 3. And that's going to be our y-axis. Now, to get the other side, what we can do is very simple. We know that our vertex is also the same thing as our axis of symmetry, basically where the middle of the graph is, okay? So if our vertex is here, and our next point, our y-intercept is here, it's only 1 away, right? So what we can do is we can kind of reflect that across the line, okay? So if I were to draw here, kind of a little axis of symmetry, right? That's the middle of our parabola. So we know, as we've seen in the past, you can flip it. It's the same thing on both sides of the line of the middle there. So if we know if it's at 3 here, it's going to stay at 3 on this side of the graph, right? It's not going to change. But what is going to change is that instead of being on here, it's 1 away from our vertex here. It's going to be the same, 1 away from our vertex on this side, but it's still going to be at 3. So now our graph looks like this. Okay. So I found our vertex using our vertex form, -b/2a. I plugged in our letters, or our numbers for a and b to solve for our x as -1. To solve for y, I plugged in what we got for x into our equation as x and solved to find 1 as our y. And then I know that my y-intercept is 3 because it tells us in the graph here. When I plotted the graph, I started with our vertex, -1, 1, -1, 1. Our y-intercept is at 3, so go to 3 on the y-axis here. I reflect, basically you can reflect it to the other side of the axis of symmetry in the middle. So if it's at 3 here, it's going to be at 3 on this side as well. Only 1 away, okay? And there you go. Now, obviously, if you want, that's just the basic part of this graph to show you kind of how it looks. So now let's do a different one, okay? Let's do one more example here. Let's do f of x equals -0.5 x squared plus 2x plus 3, okay? So once again, we need to find our vertex first. So our vertex, we're going to do x equals -b/2a. That's our formula. We're going to substitute our numbers here. So negative, and our b in this case is 2. So 2 on top over 2. And then our a is -0.5. So we're going to multiply 0, -0.5. Okay? So when we do that, we have -2. And then half of 2 is 1. And it's a negative here, so it stays negative. And -2 divided by -1 gives us a +2. So we know for our vertex, our x is at 2. Okay. Now to solve for our y, we take our 2 and we plug it back in for our x to solve for our y. So let's do that here. -0.5, and instead of writing our x, we're going to plug in our 2 squared plus 2, and remember instead of x, it's going to be 2, and then plus 3 at the end. So let's just solve. Start here with our exponents. 2 squared is 4. 2 times 2 is 4. Bring down our plus 3. Negative 0.5 times 4. So just think, what's half of 4? Well, it's 2. And we have a negative out front, so it's a negative 2. Bring down the rest of our numbers. Negative 2 plus 4 is a positive 2. And positive 2 plus 3 is 5. So our y is 5 of our vertex. And our line crosses the y-intercept at 3 again. Okay, so if we graph this, okay, our vertex is at 2, 5. So we're going to go to the right 2, x, 2, and up 5. Wow, it's up 5. So that's our vertex. Now our y-intercept is at 3. So we can go to 3 on the y-axis and graph. Now we know, once again, using our axis of symmetry like we did last time, if I were to draw quick, okay, we know that our point on this side is going to be at 3 as well, right? And we know it is 2 away from our vertex. So our vertex is at 2, our y-intercept is at 0, so we know that if we count 2 this way and at 3, it's going to be our other point. And then we draw our line, we draw our parabola. Just like that. Now, you know it's downward facing. Why that is downward facing? Because we see our number in front here is negative. Now remember, we talked about that. If it's a negative in front, it's going to open down, which it does. And our number in front is also less than 1, which means it's a little bit wider than normal, okay? It's a little bit wider than our parent x squared graph, okay? So that's how you graph in standard form. That's the basics of it. Just remember, once you have our formula here, find the vertex first, which are negative b minus 2a. Plug in our numbers to solve for our x. Use our x to plug it back in as x to solve for our y of our vertex. Our y-intercept is told to us here. It's 3. Go to our graph, vertex at 2, 5. So 2, 5, vertex. Y-intercept is at 3, so go to 3 on the y. Plot. Using our axis of symmetry, we know that it's 2 away from the vertex at 3 on this side, which means it's going to be 2 away from the vertex at 3 on this side as well. And we draw our line, okay? So this is a simple way of doing this. That's how you would do it, how we would graph our quadratic functions with standard form.